Welcome to the Building Mobile Apps with the ArcGIS API for JavaScript. My name is Lloyd Heberly. I'm a product engineer on the JavaScript team, and with me today is
Andy. I'm one of the technical product managers for the JavaScript API.
And I'm Thomas from the Zurich R&D Center. Work on the 3D parts of the JavaScript 4X API.
Okay. So show of hands, how many of you already have mobile apps that you're managing, that you've deployed? Okay, that's good. How many of you are using 4X for those apps? Okay. Mostly today, we're specifically going to be talking about 4X. I'll talk a little bit about 3X when we talk about optimizing builds, and then I'll talk a little bit more about 4X and some stuff that you can see tomorrow. How many of you are using a framework like Angular for your mobile app? Okay, a couple of you. Bootstrap? Yeah, okay. Okay, so we'll have some information in here for you for those things. So we're going to talk about the capabilities, like some of the widgets you should know about or that are, you'll be using in your mobile app. Andy will talk about managing the app lifecycle and why that's kind of important with loading and performance and things like that with the API. I'll talk a little bit about some of the things you can do to tweak your build in order to streamline load times. And we'll talk about frameworks a little bit and mobile debugging, and then we'll wrap up and Thomas will tell us about some of the work that we're doing on 3D in respect to mobile. So as you all know, the whole reason why you're here is you want to leverage and reuse your skills that you already know. Maybe you were previously a web developer, or your boss is telling you that you need to build a mobile web app, and web development is the first entry point that you've went into and decided to tackle with that. Some of the reasons why folks pick mobile or JavaScript is because you don't have to know multiple development languages like you do with some of the stuff for runtime. But so that's the expectation, is that you're a web developer, you have HTML, JavaScript, and CSS experience, and you want to reuse and leverage your skills to build mobile apps. So let's just look at some of the features or capabilities that are in the API. So after many years of dealing with networks and such, this is just much easier doing these recorded than trying to get all these network things to sync. The other thing that I'd really like for you all to do is that we can't see the screen because of the two pillars. So if any point in time during the presentation you don't see what we're talking about, please raise your hand or wave like this so we'll know that something's going on. So one of the things is that the API, it just has the built-in navigation and touch support. There's nothing that you need to do. There's no flags that need to be set. It supports, the pinch, zoom in, zoom out. You can pinch and twist and rotate to rotate the map, swiping left, swiping right to pan. One of the things that was introduced after the 4.3 API is kinetic panning. That was a feature request. So whenever it's really noticeable on touch devices, but whenever you touch and pan and throw the map, it has this sort of weighted inertia that how the map actually slows down whenever you are panning the map. So all of this is built in. There's nothing special that you need to do, and you just get it. It's just part of the API. One of the other widgets that you might find useful is if you have a specific set of base maps that you want to, like a base map and a reference layer, to enable folks to toggle between the pertinent, authoritative information that you have, that you've authored in your company or business. The base map gallery widget provides a quick and easy experience to be able to toggle between those things. The base map toggle widget, however, on the other hand, just toggles between two different selected base maps. So if you only have a specific set of reference base maps, that might be a better widget that you want to leverage and use for your app. So in that case, we were looking at just the regular base map and then the aerial. It's also helpful to provide a point of reference to get back to the area of interest in which your app loads. That's what the home widget does. So you can set an initial reference, like an extent to your app, and they can just click that button. It doesn't necessarily have to look exactly like this looks, but giving your users a point of reference to get back to where the app started is very helpful in case they get lost panning out into the unknown. The layer list is helpful, and it expands and collapses and is mobile friendly and allows people to be able to toggle on and off visibility in the app. And the layer list also has actions that you could potentially wire into there that might be helpful to perform some type of action on one of those specific layers, like change its opacity so you could see through it. The expand widget is helpful in giving an expanded and a collapsed view or drawer into a widget, and you can put, it itself is a widget, but you can put other widgets into the expand widget. So that is something that you might find helpful in saving screen real estate in a mobile viewport. The compass widget helps whenever you are rotating the map, or if you just want to have something that shows what the orientation of the map is. So if you rotate the map, the compass widget will rotate, and then you can also touch the compass widget to have it zero back to north. So that's something helpful if you happen to enable rotation on your map for your mobile app. You can also disable that too if you don't want people to accidentally do that, because sometimes when you're pinching, zooming in and out with your fingers, and you move your hand a little bit, it will rotate the map. So you can disable that. So let's take a look at how the locate widget works. So in order for your locate to work, your app needs to be accessed over HTTPS. We had a blog article about the security aspect of that, with the geolocation API not working if it's not accessed over HTTP. And essentially that button just won't show up if you don't access your app over SSL or HTTPS. So you just click the button and it'll zoom you to your location, and results are going to vary based upon your cell service and your phone hardware. One of the things that's really nice in 4X versus 3X is the pop-up experience. By default, they were designed to be mobile friendly. So whenever you have different viewports, they will dock to a specific location if it doesn't have enough screen real estate. And so the map still has focus in the view, and the pop-up is in a given location in that mobile viewport. So that's really nice. We also have another project called Calcite Maps, and it is using our Calcite web sort of theme, and basically gives you a starting point that's responsive. And if you're familiar with Bootstrap or the other types of frameworks that have grids and types and patterns and components and icons and those types of things, it sort of falls into that realm, but it's map-centric. And so this is a project that's in the SDK that you can find, and then the source code for it's actually out on GitHub. So it has things like base map switchers, and as you'll notice in this screenshot here, how the base map is down at the bottom instead of up at the top right-hand corner, since it's in the phone. And the different types of selections, like you get the different selector or picker between selecting the base map versus picking that. You're not seeing it? This one went out? Okay. So basically it's all about giving the end user a better usability experience whenever they're using a mobile device. Yeah, maybe if you toggle back and forth. Still nothing? All right. I guess just get up and make some friends. Move to the right. So if you're not using R components and you're writing your own components, some of the things you can do to make life easier for your end users is using the HTML5 input types, and that will pull up the default picker or keyboard on the phones. One other thing that's kind of a neat trick that you can do is using mobile media queries. So at the bottom next to the one, we're writing a data browser attribute into the HTML tag, and we're just putting the user agent string in there. And then whenever we write our CSS, we can say, oh, write a selector that says if the data browser is mobile, if mobile's in that string, then do a specific CSS thing. And that's helpful for doing things like putting links on things or showing things when they're on a touch device versus a desktop device. So if you wanted to be able to select that link and email it to a friend, maybe you're on your device and you're away from the office and somebody can't find something, if they're on the mobile device, that link will actually show up because of that media query. You can also do these media queries in JavaScript dynamically. So maybe it's not something that you can put into your style sheet, but it's something that you want to determine at runtime whenever they're interacting with the app, that based upon the viewport, you want to initialize or execute some code that can be done with these media queries in JavaScript. So let me show you quickly what I'm talking about here with these media queries. So if we just go into the API reference here, and let's say we go to map view, and maybe scroll down to methods, like go to. So when you see I hover over that, you see the link. Well, on a touch device, you don't have a mouse over. And if I just inject this in there immediately, now you'll see that those links show up. And that's just because I injected this data browser with the mobile in there. And if you access the JavaScript API website on your device, it will load that it'll put the user agent into that data browser tag, and then when you're scrolling on your tablet or your phone or whatever, you'll just see those links show up. So that's one trick that you can do to do these CSS things. One other thing that I wanted to show you real quickly is something that can help you as a developer is using like browser sync. So are any of you using any technology to sync screens across your desktop and tablet and phone while you're doing development? Show of hands, yes? No one? So it's really painful if you're doing desktop development and you've got your phone plugged in and then you're constantly refreshing the device to reload the app. Well, some of these frameworks and tools that you can use have basically like a live reload, and when you load the app on your phones and you have it on your desktop, as you're watching here, whenever I'm scrolling back and forth, it's doing the same activity on the device. And this is very helpful in doing live real-time testing on your devices while you're actually doing the dev on your desktop device. And so this is a way that, you know, if you are writing these special media queries targeting mobile user experiences, that you can see this sort of thing happen in real time. So it's very helpful, and it catches things early and before you you know, like get into usability and such. So I'm going to turn it over to Andy now, and he's going to talk to us about some load time issues and other things in the API.
You guys see that? Oh, over there. Okay. You see the red arrow or the red sign? How many of you have ever experienced lifecycle issues within web mobile applications? App didn't load, things didn't load in the right order. The most often misunderstood aspect of building web applications for mobile is the order in which things are supposed to load. And what I wanted to do is just talk about some of the key things to save you some time, pain, and frustration. There's many things that are going on, and when you're on a mobile device, often things are running just a little bit slower. Of course, you know from your own personal experience that the internet connection is often much slower, and that can cause all sorts of issues. And most commonly what we're seeing is it's vulnerable to timing issues. If the internet slows down and your application isn't built to run in a slow environment, things may not load in the order that you expect, and that dramatically affects the user experience, right? We want them to have a good experience. Initial loading in a mobile browser can often be interesting, to say the least. And this is just a partial list of all the stuff that's going to load in a common modern JavaScript application. You have your CSS, maybe you're using some sort of a framework.
This one's out too.
So is anything projecting?
That one's up there.
Okay.
We moved these tables earlier, so I'm thinking some of these connections down below.
Gotcha, but you guys can at least see one screen. Just hold a hand over one of your eyes. Stereo vision. You have your frameworks. You have the JavaScript API, right? Maybe you have some GIS queries that are going on, feature services. You're pulling in your map tiles. And I just wanted to emphasize this in this slide. There is a lot of stuff going on, and you're in a device. You may have the latest device, but if you have a consumer-facing app, for example, and even a lot of consumer-facing app that's running on a device, you have no control over what your users have. And that often causes some misperception. I mean, I build my apps on a pretty fast phone, and oftentimes I just have to throttle things down to see how well things load in the browser. And one of the things we often look at with web mobile applications is we want to understand the time it takes from when they first request this application until all of the application interface components are loaded and you can see all the tiles. And if you've done any performance testing, especially if you throttle down that network connection, you'll start to see that there's a significant difference from testing on an actual mobile device to testing on your laptop or your desktop inside the office. sometimes it takes you by surprise. So one of the key things we want to look at is we want to wait for framework initialization. How many of you are using third-party frameworks for mobile applications? Angular, Vue? Anybody using Vue? Oh, got some Vue people out there. Angular, for example, has an onInit event that's telling us that the Angular framework is ready to go. Cordova, any Cordova people in here? Ionic? A few. It's using the device ready event. In ArcGIS, we also have a DOM ready event. So hopefully you can see from these last few slides is that there is a lot of stuff going on and a lot of things are initializing at the same time. And I know for a lot of web applications that run on the laptop, we want to talk about asynchronous and we want to load this stuff as fast as we can. But I can tell you there are times with web mobile applications what you want to do is you're going to be loading things in a synchronous manner to enforce when things load and make sure things load in the correct order. Seems counterintuitive, but sometimes that's what we have to do. So we're going to wait for that framework to initialize. Could be Angular, for example. Then we also have to wait to make sure that all the ArcGIS API for JavaScript modules have loaded. And then on top of that, we also have to wait till the map is ready, for example. And then we're going to do something else like loading feature services. So you may have to take a step back depending on the type of applications you're building, the networks that these customers are using, and even the type of framework that you're building on. So the pattern that we talk about a lot is lazy loading modules and libraries. For example, what we're going to do is we want to wait for the map to be ready, and then we may wait to load some of the ArcGIS API for JavaScript modules to a later time. We don't want a whole bunch of stuff loading up front. We may have to move that to later on in the application's lifecycle so that we can get the performance we want on that initial load. And that may involve waiting for some sort of user input and then loading a widget or doing some other action. And so how do we do that? It's actually very simple. The most simple implementation of lazy loading is we can actually include a require statement inside the context of our overall application. And when we need something, like in this example, a point cloud layer, we're going to ask for the require statement. We're going to call the module for point cloud layer. And when we do this, the point cloud layer module isn't going to load till we ask for it. We've lazy loaded that from the initial loading of our application, and it's one less thing that the application has to process. So let's take a look at this. So this is my application. The code, since I can't see what you guys can see, here's exactly what was in that slide. I have my require statement. It's just a basic hello world application like you would expect. But when I click a button, then I'm going to go ahead and load this point cloud layer. So I have the console open down here. I'm going to go ahead and just reload the application. We can even look at the network responses. We haven't loaded anything in here that says point cloud layer. And I'll go ahead and to the bottom of the console. And what I want to do is click this button. And you can see here, although this isn't a very big file, nothing happened until I clicked that button. Sometimes you're using some of our classes or modules and it's a much larger file, or you're doing some other action in your application that's pulling down perhaps hundreds of kilobytes or even megabytes worth of data. Just something to keep in mind to make that application more performant. And here's another anti-pattern to some people, is reserving that asynchronous stuff until after the application loads. And As I was saying before, in Angular we have the on init event, Cordova the device ready event. We have the ArcGIS API for JavaScript's Dojo DOM ready event. In many cases, we're doing our asynchronous stuff for GIS after all of these events occur. We just don't want to jam up that application, cause long load times, and just make it uncomfortable for our users to use these applications. Something else to keep in mind is we get a lot of questions about when is the map view ready. So if you want to do something on the map has to be drawn first, right? For example, if you had a feature service and you want to draw some symbols on top of the map, well, because we're running in a much slower environment, we have to make sure that the map view is ready. And in the 4.x API, when the map is ready, that means the view has a map. And most importantly, and this used to be a big issue a couple years ago, we want to make sure that that map container size is greater than 0, right? Because if you go to load your feature layer and a map and the div is height 0 and width 0, what's going to happen? Nothing's going to show up. We also want to make sure that the view has a spatial reference. So I don't think the link is working. So if you go and look in our documentation for the API, developers.arcgis.com/JavaScript, and in the view reference, and if we go to map view, I'm having to do this manually because my link was broken. And we could search for the word ready. This is what we're looking for, is when this particular property switches from false to true, then we're going to know that that map's ready and all of those conditions that I was just talking about are true. And we can go ahead and do things on the map. And this is a very common thing that happens, is people trying to do things on top of the map before the map is ready. We also have in the 4.6 API a loadable pattern. And this is really handy for determining when things other than the map are ready to go, such as feature layers and tasks and web maps. Any resource where you're doing data access, if you look in the API documentation for that and you see that it has load status, this is really cool because we can tell if it's not loaded or it's in the process of loading, which could be really important. You want to get your timing right on these web mobile applications, or if it's loaded or if it failed. And so the way it works is this. This is an example for web map. This is really cool. We didn't have this in the 3.x API. How many people are building web mobile applications on the 3.x API? A few. This is one of the really nice features for 4.x that gives you that power to determine whether you're going to start something or initialize something or do something in your mobile application. Is we know it's not loaded. We can check to see if it's in the process of loading, or its load is finalized, or just simply failed to load. These are powerful tools for managing that application lifecycle. And so here's an example in code. The way we would do this is we can initialize our web map. And what's cool is, again, this is just another example of lazy loading. We can call load on this web map at some other point in the application lifecycle and ask that web map to load. And when it returns, we can check the status of that web map just by calling the load status property. Pretty cool, right? Let's take a look. Here's our simple application. Since I don't trust the internet, I preloaded this thing, but this is the exact code I was just showing you. And if you look down here in the console, we can check that load status, and you can see that it's returning as loaded. Very powerful. It seems simple on the surface, but it definitely gives you much better control over your application. We can also use splash screens. especially if you have long load time. Sometimes there's just nothing you can do about it. This is geospatial. Sometimes our libraries are large. Sometimes there's a lot of data. One of the things that we can do to sort of distract the user from what's going on behind the scenes is putting a splash screen up. And this is a GitHub repo that you can go to try this out. I'm not going to go into any detail on how it works, but just to show you, here's an example where that splash screen starts up along with the initial CSS. And I think this splash screen is like 1.2 kilobytes that loads with my application. And I'll do it one more time. And this is a very simple example, but I'm hiding what's going on behind the scenes in a graceful way. Pretty cool, right? And with that, we'll turn it over to Lloyd.
Using local builds. So Andy talked about loading. We're talking about mobile, so we're talking about connectivity, latency with your connection on your phone, all these things. I'm not going to go into a great detail about builds, but building the JavaScript API can get complex. But most of the time, I guess, whenever you all are doing your development, you're using the CDN, right? And we take our best guess at figuring out what are the most modules that are frequently used, and that's what we build into our CDN single built layer file. And then whenever you ask for modules that aren't in that build, then it'll fetch the module. So more modules, more requests, and then that's round trips that your app is making. So the reason why you would want to do an optimized build, potentially for mobile, is to target the modules that you're using in your app and then have a specific build where it's using those, and then it doesn't have to make extra requests for those other modules. So you might be doing a web application, or you might be doing a hybrid app like a phone gap thing, and you wanted to bundle the library with the app. There's pros and cons to that. Your app then is tied to the version, and you have to update that and re-update the app all the time. The pros to that is that you're not downloading the library, and it's in the application. So in the 3x world, that's what the Web Optimizer was for. And tomorrow we're going to have another session on that. But let me show you real quick where this stuff is in the API. Reference. So in the 3x world, it's under references and using Web Optimizer or using Bower for custom builds. There's a session tomorrow on this if you're interested in that. And in the 4x world, it's under working with the API and using Bower. So to illustrate this, in case some of you don't end up going to the other session, I have an app that's using an editor, and when it loads, it has 26 of 98 requests were for JavaScript modules, and the optimized build of that for the locale that it's in, which is the default is English, only 12 requests of 83 were JavaScript modules. So the less modules you have to fetch, the less network traffic that you're sending back and forth. So that session is tomorrow at 10:30 in the morning in Primrose A, which is the room that we're in now. And Andy's going to talk a little bit now, and then I'll cover debugging, and then Thomas is going to talk about 3D.
We're showing both screens. How many people are using Cordova? Nice. Ionic? Couple. Cordova, for those of you who aren't familiar with it, it lets you put a native wrapper around the JavaScript application, because JavaScript's pretty browser agnostic. It can work on a lot of different browsers like Firefox, Safari, Chrome, Edge, for example. Is you essentially build a native application. It injects your JavaScript code in there, and it runs on what is called a web view inside of that native container. And you may have actually used what are called hybrid applications without even knowing it. If you've ever flown on Southwest Airlines and used their, does anybody use the Southwest Airlines native app? That's actually a hybrid application. And the main thing to know about these hybrid applications, as I mentioned before, is waiting for that device ready event. And we have a GitHub repo that demonstrates this. There's not much to it other than waiting for the device ready event, but that can trip some people up. So we put together a repo at github.com/Esri, quick start map PhoneGap, to just show you different ways to work within this environment. So if you go to github.com/Esri, has everybody been out there yet? If you haven't, I definitely recommend that you check it out. And you search for Cordova. There's actually two repos. One is if you want to do some field data collection. We have I'm not going to talk much about it, but we also have an advanced geolocation Cordova plugin. But mainly what I wanted to talk about was the quick start map PhoneGap. It's got a bunch of samples in here, working with GPS, working with the splash screen that I just showed you, working with web maps. But I'll just show you the Hello World version just to bring home the point. This is the Hello World map. In Cordova, there's just a few extra JavaScript pieces. We're injecting the Cordova library. And if we go to the JavaScript, basic map, you can see here, we simply look for the device ready event. And in on device ready, everything else is just about exactly the same as you would expect it for a Hello World, regular desktop, non-web mobile mapping application. And the rest of these samples go through that pattern. There's a few other little tricks for working with things like navigator.geolocation if you need to access the GPS. But this is really what, once we have this tackled, almost everything's going to load correctly in the browser, and a lot of your problems should be solved as far as the application lifecycle goes. Ionic is for Angular. It's basically a mobile version of Angular. We're not going to go into any detail on this other than to let you know that there's repos out there that can help you. There's many helper libraries. Esri Loader, if you're working with Ionic, you definitely want to check that out. There's a new Angular CLI repo out on GitHub called Angular CLI Esri Map. There's also an Ionic specific getting started sample that I put out there called Ionic 2 Esri Map. That's on my own personal repo. But if you search for Ionic 2 Esri Map on the internet, you'll find it, because there's just a couple of tricks to getting things to work in Ionic. Might be a big help for you and save a few days or weeks of headbanging. And underneath the hood, a lot of these libraries are also using TypeScript, so you definitely want to check out our TypeScript definitions. Really what I wanted to tell you and just give a shout out is to Tom and Renee's session tomorrow called Using Frameworks with the ArcGIS API for JavaScript. Primrose A, 2:30 p.m. tomorrow. Great session to deep dive into learning how to use these frameworks. And most often, once you get past the framework issues, take into account the things we've talked about, then you're going to be well on your way to building a successful mobile application.
All right. Thanks, Andy. One more?
All right. So I'll just cover a little bit about debugging and testing, and then we'll turn it over to Thomas. So ideally, you have devices and you have them set up with you while you're doing your desktop development, and that stuff is loading on your device at the same time. Not everyone has that luxury. Some areas and locales have like what they call device labs, where you can actually go and test your app on these different devices and just rent time there. Some of the things you'll need to know about remote debugging is enabling it in Safari. So in iOS, you turn the remote debugging on. There are settings in Android that you want to enable your device for development. The live reload is potentially one option for you, and browser sync is a library that excuse me, a lot of these tool sets use that help do this live reload of the apps. So here's a screenshot of where you find to turn that on the web inspector. And in Android, usually when you plug in your device and you enable it, you'll get this screen that says, you know, do you want to allow this for USB debugging? If you Google it, you'll be able to find it as well. One other thing to note is these newer security policies. It's CSP, Content Security Policy. Sometimes if you can't access data or resources on the device, it's likely that there's one of these content security policies in place and it won't load the info. And finally, I just have a little video here to show you what it looks like debugging this live on a device. So you have your phones or your tablets plugged in. You've loaded the app on the device. You can open up the dev tools and do the inspect, or in Safari, and you can set a breakpoint inside of the code, and then you launch the app or refresh it on the device, and it'll hit the breakpoint, and then you can go in and inspect whatever variables are. Because inevitably, things work differently on the mobile device than they do in your desktop, and you have to figure out how to be able to debug that and test it while it's running on the device. So this will be a skill that that you will need to acquire. The last little part here is just typing in the navigator.user agent, and you can see that it spits out what the device is that it's using. So that's a way to figure out what browser version of like WebKit is running on the device. So that's all I had, and Thomas, the show is yours.
Thank you, Lloyd. Can you hear me all right? Thank you, Andy. This seems to work. All right, so is the screen on? All good? Okay. So one thing that we get with the Forex API, let me switch it back up here. I think it's better. All right. So one thing that we get with the Forex API as a bonus is the 3D part. So everything that you've seen so far and everything that you see concerning the Forex API, basically we built it such that it works out of the box in 3D as well, which is pretty cool. So let me add a third dimension to everything that's been explained so far. And I would like to quickly touch on the GPU, like the actual silicon that makes this possible, then 3D on mobile devices, how we kind of got into it, and the performance that you might see there, or that we expect you to see there, and then a short example, and last but not least, somewhat out of context but still important, progressive web apps. Just a couple of words on that one. So the progress that we've seen on the GPU hardware side has been quite impressive. This is just a short rundown of the, not like brand new, but more or less latest chips that are out there. So Apple's A10, which is in the iPhone 8, Intel's Kaby Lake, and NVIDIA Pascal, they all kind of came out in 2016. And I would just want to touch briefly on some of the properties that they have. So note that the scales, the relative scales of these chips are more or less accurate. So it's pretty impressive what Apple did here. Also the Samsung chip that I didn't put on this slide, but it's comparable for sure. So for one, they use different architectures. This is the tile-based delayed rendering, excuse me, while the others use immediate mode rendering, some of them tile-based with early Z. So there's a bit of flux in how the rendering implementation is actually done in the architecture. We 10 or 20 years ago, everything was immediate mode rendering, and then just a couple of like frequency of the clocks and how many rendering clusters those chips actually have, and then the number of gigaflops, so the number of 10 to the power of 9 floating point operations that they can do. And you can see that Apple's chip here with 500 gigaflops is almost up to speed with Intel, and NVIDIA, being dedicated graphics card, of course, wins the race, as it should be. Also interesting to see here is that like this kind of development that we've seen recently with Intel foremost, that they build their GPU support into their main CPU, which is also the case for the Apple chip, of course, kind of shows the way that things will evolve in the next couple of years. So we need to kind of get down those memory latency times, and you can do that by tighter coupling or bundling your transistors so that you can reduce that latency. So as I mentioned in the previous slide, there's different also architectures that are in place here. So the immediate mode render is what we saw in NVIDIA and ATI graphics cards for the last 10 to 20 years, while the tile-based delayed rendering, which is used in Apple's implementation, hardware implementation, is a bit different. So on top of having a complete different environment for desktop to mobile, we have like different implementations of how that stuff that we push to the graphics card, that we ask it to visualize for us, is actually processed in hardware and then put on the display. The reason I'm showing this is because some of the problems that we've seen with our API is because of this different hardware implementation, and we're committed and dedicated to finding all these differences in the hardware, even though many of those are not public, and fixing it and making it work. So just short, brief note on this one. So the immediate mode render retrieves geometry data from the system memory which needs to be transferred from the system memory to the GPU memory, and then it's able to feed into this rendering pipeline. I don't want to go into too much detail, but basically you take these vertices that you get, you project them, you throw away those that you think you don't need to render, and then you're ready to rasterize, and the rasterization then takes texture data on top of that, and you sample those textures at specific vertex positions or raster positions, and put the texture onto that pixel and start mixing those pixels to produce a final result. The main difference to the tile-based delayed renderer is that here at the early stage, it's already split up into tiles, and those tiles are already sorted like front to back, so to make sure that we don't rasterize any pixels that we won't draw anyway because they're obscured or hidden behind another pixel that we need to draw. So that's one of the advantages of this approach. Also, you see this middle layer here where it says on-chip depth buffer. So instead of having to go through the GPU memory to fetch and write stuff, this tile-based delay renderer implements like a level 1 cache, if you want to draw the analogy to the CPU, and is able to be much faster. So it doesn't need to go through that memory latency barrier. If you break it down in numbers for a simple rendering of 2 triangles, you see that these are reads and writes to the GPU memory. which the tile-based delay renderer doesn't need to do because it can cache that data. So this is basically the landscape that we were seeing when we set up half a year ago or a year ago to look at mobile support for 3D in the 4X API. We released experimental support in our last 4.6 release, also with the scene viewer. It works on most devices, but the devices that are our prime focus right now to make it work are Apple iPhone 8, iPad Pro 2, Samsung Galaxy S8, and the Tab S3. And these are the devices that we commit and dedicate ourselves to fully support for the next release. Obviously, more devices will come in the future, and obviously many devices share similar hardware properties with these two or these four, and therefore it will work. So that's neat. What's also very neat is that you can open a URL, which this one here, which will open the scene viewer for you, and you'll be immediately in that 3D WebGL GPU accelerated world and be able to pull in your data as we saw in all the other sessions. So that's pretty cool. So I showed you a bunch of differences in the hardware implementations. Of course, there's more. There's operating systems, how the operating systems interpret the calls that are made to the hardware. And then on top of that, there's also the browser vendors who put on another layer for us that we have to kind of drill through to actually get to that hardware. And that's where WebGL has made tremendous progress. We're at version 2 now, and it's very nice what we can do with it. So you've seen that the Apple chip is almost on par with desktop capabilities, but it's not there yet. We expect it to probably be on par in 1 or 2 or 3 years, that ballpark. So in the meantime, you might experience that on desktop everything works fine, while on your mobile phone it won't. So there's a couple of tips here that I would just like to put out for you to keep in mind if you experience poor performance. So keep your number of layers limited, like 10 to 30 is a good number. Use appropriate symbols for your visualizations so that they don't kind of excessively fill the small screen of the device, because the more overdraw you have, the slower your rendering becomes. Also, certain viewpoints might be disadvantageous for mobile devices because they need to render much more than if you were to, say, have a more top-down view. There's ways to throttle resource consumption, and you can also turn off features. I would also like to point out that we put a lot of effort in the last 6 months to get those resources under control for the mobile device. So the main difference that we're seeing between desktop and mobile is really the system memory. That's so much limited, so much more limited. So you've seen that the gigaflops, the number of calculations we can do is good. We're sound there, but say the Apple iPhone only comes with 2 or 3 gigabytes of memory, while the Samsung, I think, has 4. And if you compare that to typical 12 gigs that you have in a desktop or laptop today, it's not quite the same. So we put a lot of effort into throttling those resources to make sure we don't blow the memory limit, to make sure that we run smoothly on iPhones and Samsung. So this here is fake view. I told you that we're still at this current release experimental, but basically this is how it looks like. This is an example code snippet of the JavaScript API. These are all the lines you need to make the visualization that we see on the right hand side happen. There's a couple of things that I would like to show you down here. These are features that you can turn on and off to improve your actually, that's not a feature, but this is a feature, and these are settings that you can tweak using JavaScript to alter your performance. So let's zoom in here a little bit. I also have a frame counter here. So we're also dedicated to make those 60 frames per second happen on the mobile devices. I can turn on shadows, for example. This will have a little bit of an effect, so turning off shadows might help you improve performance if you're seeing problems there. Then there's the view quality profile and the atmosphere quality. So now it's on low. If you put it on low, it will use a different resolution for tiles that it displays. It will also reduce the level of detail for the scene layers that it's loading. And the atmosphere will look a bit different. So we have a pretty neat atmosphere implementation. So we're on low here now. Let me put it on high. You see it looks much cooler, but it also takes a little more resources to make that happen. All right. So Andy showed us a way with these hybrid apps how to make web pages appear in native applications as if they were native code. There's, I guess, an approach or a push for making it happen from the other side, so from the web browser itself, and it's called progressive web apps, and specifically service workers. So the idea that Google had there was to allow an application to specify what it really needs to be considered almost like a native app. So what does it need to quickly load, and how should it display on the home button, on the home screen. And if you do that stuff right, and I will show you later on the Samsung phone, it's pretty neat. It works. So the idea is that you use a service worker, and the service worker API requires you to register a JavaScript file, which will be the service worker. And if that registration is successful, then the service worker is active. If the controller is set, if there's no controller, the service worker has been installed but is inactive yet. And if there's errors or if there's no service worker implementation in the current navigator, we bail out. So the idea was that you can, if everything required to make a progressive web app happen is available, then Google Chrome will show you install this web page as app on my home screen, and this is the install phase. So it will then launch the install part of the code and put that app onto the home screen. Here we see the service worker implementation that we referred to in the index HTML before, and here we see that install phase. There's also an activate phase, so say the app was installed and I'm now launching it, I'm starting it, then we're in this activate phase, and fetch phase, or the fetch event here, is actually implementing the kind of network request manipulation. So the idea of the service worker is that it runs as a separate thread within the browser process and is able to service network requests independently of what, say, the application JavaScript thread is doing. So in this install phase, we wait until the cache that we have control of, and I called it cache version 1 here, is ready, and then we add to that cache the index.html file. Typically, you would want to add all the static data, that is all your JavaScript, all your CSS, all your HTML, but you can also add tiled images from a tile image server or service, or any other thing that you would really like to have available offline. And then for the fetch event here, in this simple example, we respond to this request that we get from the JavaScript application. We respond with opening the cache, and then once we have the cache, we search if there is the request that we're seeing from the application, if it's present in the cache. If so, we return the response from the cache. If not, if this cache item doesn't exist, we pass on this request to the network and actually retrieve it from wherever it originally came from. On top of the service worker implementation that you need to provide to make the progressive web app happen, you also need to provide a manifest. It's a short file that kind of tells Google Chrome how to put your stuff on the home screen in a way. So you refer to that in the index HTML with a relative link to a manifest, and the manifest is really just a short listing of what the name of the app is, an array of icons at different resolutions that it should use for visualizing it in whatever context it needs, and where to start, and a bunch of color thingies. All right, so to drive that point home, let me switch over to this Samsung Galaxy app, and what I would like to show you is the hiking app that you saw during the plenary. So it's an application written in the JavaScript API, and so just to make this really convincing, let's go to flight mode, so no network available. Here's that hiking trails app in the middle of a screen. I'm opening it up, it loads, I go to the map, and it even starts fetching data, and just give it a second, and display that hiking app in a partially disconnected mode. So what's important to state, I think, is that this is not a replacement for like the runtime API where you can package and deploy truly native apps. It's more, think of it as a way to handle partial disconnects where you can tell or have a tighter control on how the cache that the browser is holding on to anyway, how that looks like over a longer range of time. So it doesn't purge the cache automatically, say when it reaches a certain size or when it reaches a certain age, but you control how the cache is treated. Yeah, so that's it. All right, so one more time to Andy.
What do you guys think? Pretty good. I know we're at the hour, but if you have questions, we can take a couple and then we'll shut it down and you can come up here and ask us other questions. Anyone have a burning question? Yep, over there. Burning question.
Yes, it is.
The question was, is the hiking trail app available?
It is.
It is.
I can.
Any other questions? Bootstrap 4 support for calcite maps. Yeah, we can find out. We can get that question for you afterwards. Don't know off the top of our heads. Yes. Correct. The question was TPK layer. There was a project specifically for the 3.x API, and it was related to taking TPK, to reading a TPK layer, and that could be used offline. At current, there's no plans to include a TPK layer in the 4.x API. Any other questions? All right, well, we'll be up here. Thanks, everybody, for attending. Appreciate it.